Good afternoon. How are you today? So we are in week 2, lab number 2. We are going to implement two root finding methods. Our object is to find the non-zero root of this function 2x squared plus 1 minus e to the power x. You may remember this. You worked with this function in lab 1. You plotted the function, found its non-zero root by bisection method. So today we are going to implement it Newton-Raphson method to find the root of this function. We are going to have Newton-Raphson find it to 4 correct decimal digits. And then we are also going to implement secant method to find the root to 4 significant digits. So I had asked you to prepare templates with the workbook name lab2.xlsm. So let me fire that up. So in my case, it warns me I'm going to enable the macros. So I'd asked you to bring two worksheets, Newton and Secant. So I have two worksheets here, Newton and Secant, and a VBA module containing 4 functions. So here is our Newton-Raphson method. Here is our secant template. And then I wanted you to have 4 functions in your Visual Basic module. So let's go to Developer tab, Visual Basic. And I have 4 functions. The first is our function f of x. We want to find its root. Second is its derivative. So we take derivative of 2x squared, we'll get 4 times x. Derivative of 1 is 0. Derivative of e to the power x is e to the power x. So this derivative function df requires just knowledge of x. Then we have the dx by Newton method, which is just the ratio of function to its derivative. And finally, we have dx secant, the second method that we are going to implement, and I'm going to talk about it later on. Okay. So we are going to find root to 4 correct decimal digits by Newton-Raphson method. So let's begin naming cells. So this is our X initial, this is our initial guess. EABS, absolute criteria, because we want 4 correct decimal digits. So it is 4 zeros, 0.5 times 10 to the minus 4. And always a good idea to check the names again. So we go to formulas, name manager, and we have 2 names, X initial, EABS, in this Newton worksheet, and these are the values. Okay, now let's populate our spreadsheet. Iteration is equal to 1. X is equal to X initial. Then we'll evaluate the function at this X value. Evaluate the function prime, df, same X value. Then we are going to calculate delta X. Okay, we are going to calculate the delta x value using our dx Newton, which requires again our x value. And then finally, we'll calculate x nu, which is x minus delta x. Then we are going to check our convergence criteria. Absolute of delta x, is it less than equal to EABS? And we have not converged. Then we are going to increment our iteration number by 1, and our new x value becomes our next guess. Okay, so notice this was our initial guess. We did all of these calculations. This is one whole row worth of formulas. So that's all we will be doing throughout the course, one row of formulas. So you have to type them carefully. Okay, so we'll copy using the copy fill tool, one row down. Still have not converged. Let's do one more. And we have converged in 3 iterations. So we want to format all our x values. So this is x, this is x, this is x, to 5 decimal digits. Okay. We'll format f and f prime values to 1 scientific digit. The reason is because their magnitude can change quite a bit. We are going to enter our output. Our root is 0.74085 plus minus. So we insert symbol plus minus. And we need to find something. This 0001 may have a digit. It may be rounded up, it may not be rounded up. So let's check what is beyond there. So we'll just temporarily increase the number of digits. So we see it is 00012, so we have to round it up to 2. So even though it shows 1, we want to make sure that our error bound is always conservative. And we did it in 3 iterations. So let's bold this also, box and bold. And that's it, folks. We are done with Newton-Raphson method. Let's go to secant method. So we have this template, and let's start naming our cells. So this is our first guess. Just to accentuate, I'm going to capitalize 1. This is x2. And this time we want 4 significant digits, so we are going to use relative criteria. So this is EREL. And that's it. Again, get in the habit of checking using name manager. So again, in name manager, we just added these three formulas. Okay, so first iteration equal to 1 equal to x1. This equals to x2. This is function at x1. This is function at x2. And again, we are going to use the dx secant now, which requires two values, x1 and x2. Now I want to comment on some of these. We really, when we are doing spreadsheets, this function values, I am just calculating just for display, intermediate, checking purposes. But if these function values are expensive to calculate, you don't want to calculate them repeatedly. And that is one of the reasons why we need to be careful. So let's suppose the function calculation was expensive. So what we don't want to be doing is here, if we just don't store these values f1 and f2, then we will be calculating f2 value twice. So we should really reduce number of function calculations if they are expensive. So be careful in programming. Often when people use packaged functions, often they are evaluating expensive functions repeatedly, and that increases their computation time. Okay, our x new is x2 minus delta x. And then we are going to have our convergence criteria. Absolute of delta x divided by x new, is it less than equal to E relative? And we have not converged. So we are going to increment our iteration number. Our new value is the x2 value. For x2, the new value is the one we just calculated. Okay, so we have finished one iteration. That is two iterations. And now we just use our iterator. Three iterations, four iterations, and it converges in four iterations. So this is our answer. Let us report it. Let's format first. But before we format, let's take a look at what happens if f1 becomes equal to f2. Let's suppose we keep on calculating. So we keep on calculating. We have converged, but eventually you see it gives us this value error because f1 becomes equal to f2. So when f1 becomes equal to f2, then we have division by 0. And that is why we are getting this error. So we need to take care of it. So we want to use this formula only if f1 is not equal to f2. So what we will do, we are going to say that if f1 equals to f2, then let's see, maybe I've not written it exactly like that. So let's make sure. Let's say if we want to use this formula if f1 is not equal to f2. So let's make it not equal to. If f1 is not equal to f2, then only we use the formula, otherwise delta x is 0. So of course, we just change this formula. We'll just copy it down. Remember, we had converged in 4 iterations. So we just did this to show you how we get that error. So now all our delta x has this if statement. So if we copy this down, you can see we don't get that value error. Instead, delta x just becomes 0. So let's erase all that. Let's format x values to 6 digits this time. You will see that we are getting more than 4 significant digits, really. And f values to 1 scientific. And we have this as our output. So let's format it, bold, box. And again, we want to peek at the next digit so that we will know whether to round up or not. So when we peek, you can see the 7 should become 8. So our root is 0.740850 plus minus. And we have, you can see 3 to 5, 1, 2, 3, 4, 5 zeros, and we round it up to 8. So we want to match number of digits always. And we did this in 4 iterations. So you might note now we have a trailing digit, trailing 0, which is considered significant in this case. So that's our answer. So let's check our formatting, make sure our printing and everything is all set. So we are going to go in File, Print. So we are missing grid lines, etc., etc. So let's do Sheet, Grid lines, row and column headings. Okay. So everything fits nicely on one page. We are good. Let's go look at our other sheet. File, Print. We need grid lines, etc. So page setup, sheet. You want grid lines, row column headings. Okay. Again, everything fits nicely on a page, so we are all set. We have names on our sheets. Everything is good. So now we can do File, Save As, and I want to save as lab2.xlsm. And that's it, folks. We are done. You can submit 2 assignments in my courses. Have a good day.